Hello YouTube, Sidekick here, and I'm here in an AV-8B Harrier. Not to talk so much about the Harrier, but to talk about a particular system that comes with the Harrier, and that's the angle rate bombing set or angle rate bombing system. It gets mentioned in a lot of the Harrier manuals, but not a lot of time gets spent on it. I think it's interesting because it's part of the transition from unaided iron bombing to modern precision-guided munitions. I mean, part of the reason it gets kind of glossed over in the Harrier is because the version of the Harrier that we have is capable of using the Lightning targeting pod and a lot of very modern precision-guided munitions. And so we kind of walk past the configuration that the Harrier was in say, the late 1980s and 1990s when the ARBS and the dual-mode tracker were really kind of the height of technology. So I'd like to take a little bit more of an in-depth look at the ARBS in this video and talk about how it kind of bridged the gap. The ARBS, or ARBS, came as standard equipment on the AV-8B right from the beginning when it appeared in the late 1970s. The ARBS itself was developed in the 1970s, and so it was developed really based on the experience of the United States in Vietnam and probably the Israeli experience in the Yom Kippur War, I'm guessing. Now, there isn't a lot out there on this, so I do have to admit that I'm kind of guessing at some of this, but I think I'm probably close. So when it was being designed, the US and the Israelis had experience with the A4E and then the A7 in the Navy, which had bombing computers. They also had experience with the F4 and the A6, and the Air Force had experience with the A7, and they had also been using laser-guided bombs for a number of years. But when the Navy started designing the AV-8B in the mid-70s, they obviously wanted something that was better than what they had in those aircraft. So, based on the description of the system, here's what I think they might have been trying to improve. To understand it, first of all, you have to look at the state of, let's call it, Ordnance prediction in 1970. In this situation, we basically are going to use a computer to predict where our bombs are going to land, and the basic idea is that the computer knows the aircraft height and direction, the speed of travel, and the flight characteristics of the bomb. So it can calculate a projected impact point. It can either show that impact point to the pilot, which would be a CCIP system, or the pilot can tell the computer where he wants the bomb to hit, and the computer can drop the bomb at the right moment, which would be a CCRP system. But the quality of the computer's prediction is strongly affected by a few things. First, the altitude above the target. This will be particularly a problem in uneven terrain, such as the U.S. typically encountered in Vietnam or Korea. Secondly, aircraft speed and direction. This is probably strongly affected by wind, and more so the higher you fly. And of course, flying higher to avoid AAA was becoming a bit of a priority in the mid-70s. Now, I'll also mention that I think we're a little bit spoiled in DCS, because I'm not sure that these factors are particularly well modeled in DCS, and I think our various CCIP and CCRP systems are probably a little bit optimistic in terms of what they model in terms of their performance. Now, the other thing we should note is that the quality of the prediction that the computer was able to provide was strongly influenced by the pilot's ability to see and designate the target correctly, and that ability required getting close to the target, but increasingly getting close to the target enough to be able to identify it by eye meant being inside the lethal range of the air defenses. Now, these problems could and were being overcome with laser-guided bombs, but the aircraft of the time had no way of actually identifying the illuminated targets. So they could set up a bomb and drop it on a target it had acquired, so long as they knew approximately where to fly to find that target. Again, though, that required visually being talked onto the target by the designator, which meant getting closer to the target than they probably really wanted to. So I think ARBS was designed to address these issues. First of all, to counter the first two problems, instead of just taking instrument readings, the system would identify, register, and track a target, and it would then use the changing angle and the rate of change of that angle to improve the calculation of the range to target and the rate at which that was changing. This provided a significantly more robust prediction than simply depending on either a radar altimeter or an air-to-ground radar and the aircraft's own airspeed indications. This feature of ARBS probably doesn't matter all that much to those of us in DCS because, again, our bombing computers are probably a bit more accurate than they really should be, especially our CCIP computers. So while we're able to drop bombs pretty much as accurately as we want to using CCIP, I'm not sure that pilots in the early 70s were having experience that was quite as good as the one that we get in DCS, and so they might have been looking for something that was a little bit better. The second feature of ARBS, which is the most obvious improvement in DCS, is the addition of the dual mode tracker, and here dual refers to the two modes, the first of which is the magnified optical sensor. I couldn't find data on the magnification, but it looks like it's around 10x to me. And a laser source tracker, which can identify the source of reflections of a laser designator. In other words, it can find the target that's being illuminated. The optical sensor was also enhanced by being able to lock onto targets using video contrast and then be optically stabilized so that the target could be kept in view while the plane moved, so long as the target stayed within the gimbal limits of the sensor. This meant that the pilot could identify a target from a much greater distance, and he could refine his aim using the stabilized and magnified video. When this functionality was combined with a new fully functional HUD, some of which were now becoming available in the 70s, it meant that the pilot would be able to identify the target on his HUD and either attack it automatically using CCRP or just by using CCIP, but with a highly visible target symbol on the HUD. The laser sensor, on the other hand, meant that the pilot could, even at a fairly long range, just point his aircraft in the general direction of the target area, and again, the target would appear on his HUD. He could then deploy a laser-guided bomb if he had one, but if he didn't, he could actually also manually designate the target, and again, he could attack it with either CCRP or CCIP and just using iron bombs. So as you can see, ARBS with the DMT really was kind of like an early form of a lot of the functionality that would eventually be present in modern targeting pods. In fact, one kind of suspects that the experience, or even the rumors of the functionality of ARBS, is kind of what drove other manufacturers to develop external solutions that would provide similar functionality to the one that Hughes was providing internally to the Harrier and the A4M, which is ultimately what led to the targeting pods. But that's pure speculation on my part. At any rate, that's the story of the ARBS and the DMT. Let's take the Harrier out to the range and see what we can do with this system. Okay, we're getting ourselves out to the runway here. Once again, we're at Kobuleti. We're on our way to the iron bombing test range. We are sporting today the absolutely fantastic RCAF fictional livery for the Harrier. Wouldn't it be lovely if Canada had AV-8Bs, but we never did. And that doesn't mean that I can't dream a little when I'm flying in DCS. So now, we're just getting set up, doing some final checks here. I just wanted to give some credit where it's due, because I don't think I've done that enough in the last little while. First of all, the test range, as I call it, really is a test range because it is instrumented with the target information tracking script, which is wholly and completely the invention of Draken, and who has spent a great deal of time helping me make it work on the range, making improvements to the script, and I really do owe him a debt of gratitude for all the work that he has put in. The script really is an excellent tool because it not only gives you the accuracy, it gives you the launch parameters, and now it also gives you roll-in parameters. So it's a tool for helping you actually improve your flying and your results. I think it's great, and I don't say often enough how great I think it is. So thanks, Draken. All right, we're getting ourselves off the ground here, which is always fun in the Harrier. The Harrier really is a fun aircraft to fly. I had forgotten how much fun it was until I was recently over on the Yappy Dog Tactical Training server, and they're forming a little group over there to help each other learn the Harrier. And even in just a short period of time, spending a bit of time with those guys, I remembered how much fun the Harrier was and learned a lot. So if you're starting out on the Harrier, dropping by the Yappy Dogs Discord server, and I'll put the link in the description of this video, and trying out his tactical training server, there would be worse ways to learn the Harrier, I think. Okay. So we're going to climb out here and get ourselves sorted out, and I think what the plan for the exercise today is going to be, as per usual, we do have 4 bombs on board. I'm not sure if I'm ever going to use 4 at a time. I do have ammunition set to unlimited, so they will replenish every time we drop them. And I think what I'm going to do is I'm just going to start off by doing some straight CCIP runs, just to kind of get a calibration of how well CCIP works in the Harrier. And I don't think that I am providing any spoilers when I say that it works pretty well in the Harrier. In fact, as I said, I think we might even be a little bit spoiled by how well a raw CCIP actually works, to the point that it kind of maybe obscures exactly why the DMT and the ARBS was actually seen by pilots as actually being quite a significant advance in the Harrier. The pilots really did like the system. If you read any accounts of the first Gulf War particularly, the Harrier pilots had learned to use the system and learned to rely on it and really depended on it to be able to particularly drop bombs accurately from relatively high altitudes. Roll-in heights often in the Gulf War, in point of fact, were between 15 and 18,000 feet. And especially by the end of the war, when they were becoming concerned about manpads, they were trying to drop the bombs at 8,000 feet. And I'm not even probably going to be able to do that well today. I certainly don't on a regular basis. But it just gives you some kind of idea of exactly how the precision that was demanded. If you're going to drop bombs accurately from altitudes like that, you really are going to have to be pretty precise. Okay, so we're just going to go and do a very simple, straightforward, no frills CCIP bombing run on the standard big circle target there. Again, one of the great things about the Harrier that is different than especially earlier iron bombers is the visibility from the cockpit is really fantastic. So you have a lot of options in terms of keeping the target in sight. As you approach it, you don't have to do the 90-degree approach and the big roll-in that we have to do with earlier aircraft like the A4. Here we go. And there we go with the pickle. It's just that easy. Didn't really try to do it from any particular altitude, just kind of setting up to see exactly what we get on a kind of a very standard CCIP run. And obviously the accuracy was good. Let's just see what the script actually has to tell us. Well, 4 meters from accuracy from 4,000 feet. Pretty hard to beat that with a stick, as they would say. It was a medium dive angle, 30 degrees. So let's do a slightly more standard roll-in approach this time. I'll try to get up a little higher and try to approach the target sort of from 90 degrees and do a little bit more typical roll-in. And once again, see if we can drop even higher than that. So we're just going to pull around here to the left. The trick, of course, to dropping the bombs from high altitude, the trick with just about any iron bombing run is, of course, the roll-in. We need to roll in quickly. We need to get the flight path vector onto the target, and we need to get the bomb fall line lined up so we can get the pipper up to the target. The more efficiently we do that, the higher we're going to end up dropping. But we do want to avoid a lot of strong pulls on the stick, because even with CCIP, that will disturb our accuracy. So we're putting the lift vector on the target, rolling out with the flight path vector on the target, and now I just got to get the line to the bomb fall line lining up the cross with the middle of the target. This takes a little bit of jiggling, and I really want to stay quiet on the stick now, and now I probably could have gotten up to the target a bit faster if I pulled up, but I'm not sure that I would have gotten exactly the same level of accuracy Because even with a CCIP pipper, if you are putting Gs on the aircraft, you are going to end up with slightly worse results. So anyways, let's see if that's borne out by what we see in the target information tracking script here. Okay, well, it was certainly accurate, but it wasn't any higher. So maybe I should have tried to get the pipper up to the target just a little bit faster. It's a little bit steeper dive that time, though. Anyways, that run felt pretty good. But I really would like to try and, let's give it one more try and see if we can get the drop altitude up just a little higher. In any modern environment, or even a 1990s environment, 4,000 feet is probably a little bit low to be dropping if you want to ensure that you're going to come home from the mission. So let's see if we can get up a little higher, get on the target just a little bit faster. And see what kind of drop altitude we can get if we're really working at that. So once again, just shaping it around, waiting until I'm about in the right spot. Nice smooth roll in. Lift vector to target. Pull up the flight path vector. Oh, need to put it in CCIP mode there, air to ground mode. All right. Now, get it on, and now accelerate the pull up a little bit so we get it up to the target earlier, and there it goes. And we'll have to see what the target information tracking script says about that. Okay, while we're waiting for those results, let's talk about what to do next. I think that's enough of just using straight CCIP. So I think I'm going to back up a little farther on the next one and actually use the ARBS system, and probably use it in a more kind of shallow dive or level bombing mode, see what we can get doing that. But I'm interested to see just how well we did there. Okay, well, it kind of bears out what I was saying before. I mean, 13 meter accuracy is certainly more than sufficient for most targets, but it is a little worse than we did before, and I think maybe that's the price we pay for just being a little bit more aggressive on trying to get the pipper onto the target a little faster, which we did do. Dropped at 6,000 feet, which is probably not high enough for the pros, but it's pretty good for a third try, I think. So let's just go back down the coast here, because one of the things about ARBS that really is impressive is that it really provides you with the opportunity to designate the targets from a long way away. That's really the advantage of having a magnified sight. So I just want to get the DMT up on the screen here. And I think that was one of the real breakthroughs of the ARBS was, in other aircraft, even with a good CCIP pipper, your ability to achieve any kind of standoff is pretty much limited. Like I'm thinking of the Viggen, for instance, that has some great standoff weaponry, but it's very hard to be accurate because you have an unmagnified view of the target, and when you're far back from the target, you just have limits on how accurately you can designate it. I'd say the Mirage 2000 is the same way. Very accurate bombing system, but you do have to get close enough to see the target to be able to hit it. So I think that was one of the really big advantages of the ARBS system, was coming with the DMT. And as I said, I think once pilots and once services saw how the advantage of that, I think that's really one of the things that drove the development of the targeting pods, which I think came a little bit behind ARBS. It's a little bit hard to tell when these things were first conceived and worked on in the lab, but I think that's probably, you would find, the order in which things happen. So now we've got the DMT ground stabilized, and we're just going to try and put the target cursor over the target, and you can see we get a pretty good view of the target. We can refine that pretty accurately. And now I'm still in CCIP mode. I need to go to auto mode. Okay, and now I just need to stay lined up on the bomb fall line. Well, first I have to get on the bomb fall line. And then once I'm on the bomb fall line, I just have to fly straight. And I'm in a shallow dive. I could probably pull up a little, but again, that might introduce a little bit of error. And I just need to stay here until I get the release cue, and then I'm going to pickle and wait for the release cue to come down, and we'll see how accurate we can be basically flying. This is almost a real sort of classic level bombing CCRP kind of mode right now. You can see we're above 6,000 feet, so not bad. And there go the bombs. And now we'll pull off and we'll see what tale the target information tracking script tells. Okay, so that was a run where we actually used it in full sort of auto bombing mode. I want to do another run to use the DMT just in target designation mode, let me call it, where we're actually still going to use CCIP to deliver the bombs, but we're going to use the DMT to actually designate the target a little bit more accurately or a little bit more obviously so we can see it on the HUD. But okay, so what do we get? Well, a little bit worse accuracy, 20 meters, still nothing to sneeze at, but not as good as any of the CCIP runs. But 6,700 feet, and that could easily have been higher if we had been wanting to make it higher. So I think that demonstrates the value of the ARBS. And again, I suspect if we were using slightly less optimistic physics, that our CCIP results, if we had any kind of wind, if there was any kind of variation in things, any kind of noise in the radar signal, that I'm not sure that we would be getting, breaking the 10-meter circle with CCIP from 6,000 feet or 5,000 feet. So we might actually think that was a pretty good result if we had a slightly less optimized CCIP system. But that's the way DCS works, so we'll have to take it. Now for this run, what I'm going to do is I'm going to use the DMT to designate a target that would be really difficult for me to see from any kind of altitude. So it's marked as a waypoint, so I know approximately where to look with the DMT. It's basically a group of M113 armored personnel carriers. And from altitudes like we're talking about, above 10,000 feet, that's not a target that's going to be easy to identify. So what we're going to do is we're going to use the combination of the waypoint. We're going to use the DMT, and stabilize it there. Going to move it over to actually get it in the target area. And when I find those targets, I'm just going to leave the designation on it so that I know where the targets are. Okay, so there's the group of APCs. Maybe I'll move it. I'll leave it there. Now I'll put it in the middle of the group. Now I don't actually have to continue the bomb run there because I've gotten a little bit lower than I really wanted to be. So now I'm going to go around and do a 360, gain some altitude, and then I'm going to come back over and I'm just going to use CCIP mode, but this time my HUD is going to have a nice clear indication of where the target is, so I won't actually have to try to find that target as I'm approaching and rolling in. So again, just showing the value of having that magnified view in the cockpit. Even if we don't use it to augment the bombing accuracy, it really does provide us with a better system for actually seeing targets. And again, I think this is why the DMT and the Harrier really inspired the development of the full targeting pod solutions that you eventually see, because they weren't that far behind. Okay, so we're shaping our path around here. We know approximately where it is down there in that open big open space. So I'm keeping that off the left-hand side of the cockpit, just trying to gain altitude, going up past 15,000 feet. So I'm basically going to see if I can drop a bomb from this altitude, take out a vehicle at this kind of altitude. So we're rolling in around 15,000 feet. I'm just going to wait a sec. There's the target. There's the bomb fall line. Oops, I don't want it in auto mode. Change it to CCIP. There we go. We can do that quickly. And now it's just a matter of trying to get the cross over the dot and pickle and pull away. So still not a bad. Probably could have been a little bit higher up if I had my switches set up properly before I rolled in. But even at that rate, we managed to drop at a decent height, and it looks like we claimed ourselves an M113. So I'll be interested to see what the target information tracking script says. Not for the accuracy this time, but I am kind of interested in my release parameters. So we should get that here in a sec. So yeah, we rolled in at almost 15,000 feet, dropped at almost 6,000 feet. And I don't think that I would have been able to achieve that level of precision if I had had to try and eyeball those targets. I probably could have seen them. But it would have been kind of iffy to figure out if I could get the pipper on them from that altitude, or at least that quickly. So I think that shows another advantage of using the angle rate bombing system and the dual mode tracker in the Harrier. A couple of different ways of using the technology. As I said, I think it's underappreciated in DCS just how much of a technological advance it was. Again, because I think we're a little bit spoiled in that our basic bombing modes are probably a little bit more accurate than they would be in real life, and so the augmentation that provides is maybe a little less obvious. But I still think it's an excellent system and one that's interesting to play around with in the Harrier, just to see the development of those kinds of systems. At any rate, I'm going to stay out here, practice some more. For now, this is going to be Sidekick, signing off.